Welcome to the Explainer. Today, we're going to unlock an absolute superpower for your Haskell development workflow. If you write Haskell, you already know the ecosystem is incredibly rich. But let's be honest, navigating it can sometimes feel like digging through endless source files just to remember, argument orders. We rely so heavily on type signatures to guide our architecture, but tracking them down really shouldn't be a chore. So today we're focusing on mastering local API discovery using a fantastic tool called Hoogle. I'm genuinely so excited to guide you through this because optimizing your local environment is hands down one of the highest leverage things you can do for your productivity. We're going to take your setup from standard to highly customized in just a few logical steps and hopefully reclaim hours of your time.
So, let's start with a question that gets right to the heart of the matter. What is the fastest way to find a Haskell type signature? Think about your current workflow for a second. When you're deep in the zone, flow state fully engaged, writing out some complex logic, and then you suddenly forget the exact signature of a function. What do? Do you break your concentration, open up a browser window, navigate to Hackage, and start searching the web? That context switch is a massive developer pain point. Every single time you leave your editor, it takes precious minutes to get that focus back. Setting up the ultimate, frictionless path to answer this exact question right where you already are is our main goal today.
And that brings us to the core use case right here. Finding the type signatures of a particular function quickly. Hoogle is absolutely the perfect solution for this. Once you've got Hoogle to generate a local database correctly and, maybe apply a little patching if you needed to handle some specific compiler version mismatches in your setup, it transforms into an incredibly powerful engine for API discovery. It sits right there on your machine, completely pre-indexed, ready to serve you exactly what you need. No internet connection required and definitely no slow web searches.
All right, let's kick things off with level 1. Searching in the console.
To establish our baseline here, just pop open your terminal and simply type Hoogle template error. It's literally that easy. You're just calling the Hoogle executable and passing it the exact string you want to search for. There are no complex flags, no convoluted syntax to memorize, just the command and your target. This is the bedrock of local API discovery. You ask a simple question and your local index is queried instantly.
And look at this. Notice how Hoogle doesn't just spit back simple functions. It instantly finds data types, new types, and specific constructors all across various libraries. You search for template error, and boom! Hoogle scans your local database, instantly surfacing a data type in headroom.template, a new type in network.uri.template, a relevant function signature like template error pretty, and even specific constructors from text.pandoc.error. It gives you the exact type signatures and tells you where they live, without overwhelming your screen with excess formatting. It's clean, incredibly focused, and you can act on it immediately.
Moving right along to level 2, integrating with GHCI. Now, console searches are great, but what if we want to bring this search capability directly into an active, interactive coding session? Well, if you want to use Hoogle within GHCI, you use this command right here. You're at the prompt, and you just type : Hoogle template error. The real magic is that : syntax. In GHCI, : tells the interpreter to escape out to the underlying shell, run whatever command follows, and print the result right there in your interactive session. You get the exact same brilliant results we just talked about, but you never actually leave your workflow context. You stay completely in the zone.
Ready to step it up? Level 3. Customizing your workflow. Now, what's really interesting about this slide is the contrast between the two approaches. Manual execution gets the job done, for sure, but it's raw and repetitive. Having to type out that shell escape sequence every single time introduces just enough friction to be kind of annoying. By introducing a custom .ghci command, we shift completely to automated execution. This lets us hard-code set parameters, saving keystrokes and mental energy every time we need to look something up. Basically, we're transforming a multi-keystroke chore into a seamless, native-feeling command. Let's actually deconstruct the mechanics operating behind the scenes here step by step. First up, we define the command with a simple lambda function. We use def Hoogle, followed by our lambda. This tells GHCI that whenever we type -Hoogle, it should take the following string argument and pass it right to this function. Second, we smartly append our search string. We construct a shell command string and concatenate it with our search term. Notice the elegant little inline logic there, checking if the string is null. This smartly prevents errors if you accidentally hit enter without actually typing your search term. Finally, we cap the output at 50. If you've ever accidentally searched for a super common type like string or int, you know it can completely flood your terminal buffer.
Appending -count equal to 50 ensures your results stay highly manageable. Add this block to your .ghci config, and you've just secured a massive quality of life upgrade.
And finally, we arrive at the boss level, running the local server.
As great as the terminal and GHCI integrations are, spinning up a local web server instance is actually the absolute best documentation experience you can have for Haskell. And look how incredibly simple the command is. You just open your terminal and type Hoogle server. That's literally it. What makes this the ultimate option, as our source material points out, is that a web server allows you to interact with the documentation visually. Most importantly, you can click and link directly to the actual source code and expanded documentation for the types and functions you're discovering. It transforms a static block of text into a deeply interactive exploration tool, letting you drill down into complex type hierarchies with just a simple click.
Server started on port 8080. When you see that simple line pop up, you know your isolated, lightning-fast documentation environment is fully operational. It's honestly a fantastic feeling, knowing you have the entirety of your project's documentation sitting securely and instantly accessible right on your own machine. A quick glance at the startup logs proves exactly what's happening under the hood here. Check out that read time, 0.00 seconds. That shows just how incredibly lightweight this initialization is. You aren't booting up some massive, resource-heavy enterprise tool. You're launching a highly optimized index. The server binds immediately to port 8080, totally ready to handle your browser-based queries without a single hitch or delay.
So, let's recap. We've gone from a simple raw terminal query, seamlessly integrated it into our interactive GHCI session, deeply customized our configuration for maximum efficiency, and finally spun up a dedicated local web server. The infrastructure is entirely in your hands now. You've transformed a disjointed search process into a customized, local powerhouse. The real question is, how much deep focus will you reclaim now that the entire Haskell ecosystem is sitting right on your hard drive? Fire up Hoogle and find out. Thanks for joining me on this explainer, and happy coding.